Today we're going to do these two problems to help us understand how to take some trig derivatives. So problem 1, take the derivative of ln x sine x plus x squared cotangent x. I've written down all the things we need to memorize on the right hand side as well as the product rule formula, which will come in handy later. So we see that we have to take the derivative of two terms added together. So we can just treat this as two separate derivatives. In other words, we need to apply the product rule 2 times. Starting with ln x times sine of x, we see that we can define u as ln of x and v as sine of x. So then we take the derivative du dx, and if you'll recall, we need to memorize that the derivative of ln x is always just 1 over x. And then taking the derivative of v, dv dx, that's going to be cosine x, as noted on this side of the screen. So now we can apply the product rule, which says that dy dx equals u times dv dx cosine x plus v sine x times du dx, which is 1 over x. Simplifying this, we could say the answer is ln x cosine x plus sine x over x. But we're not done yet. We still have these two terms that are multiplied together, so we need to apply the product rule a second time. We could define u here as x squared and v as cotangent x. Du dx equals 2x. dv dx equals negative cosecant squared x, as written up here. Applying the product rule once again, we know that dy dx equals u, which is x squared, times dv dx, which is negative cosecant squared x, plus v cotangent x, times du dx, which is 2x. So let's simplify that further. We have negative x squared cosecant squared x plus 2x cotangent x. Don't let cosecant and cotangent intimidate you. We can just treat them as a simple x term. So now that we've taken the derivative of these two terms, we just add together our answers here. So the final answer is dy dx of the given problem statement equals ln x cosine x plus sine x over x minus x squared cosecant squared x plus 2x cotangent x. We could simplify this further if we'd like, but this is good enough for now. Moving on to problem 2, I once again wrote down everything you need to memorize and the formula you need to apply for this problem, so let's get right into it. We see that we have one term over top of another term that we must take the derivative of, which is a surefire sign that we need to use the quotient rule. So let's do that. U equals secant x, v equals the bottom term, ln x plus 1, du dx equals, if we refer to up here, secant x tan x, and dv dx equals 1 over x. Now simply just applying the quotient rule, dy dx equals du dx secant x tan x times v ln x plus 1 minus u, which is secant x, times dv dx, which is 1 over x. All of this over v squared, which is ln x plus 1 squared. So that's all for this video. I'm just going to leave you with the following definitions that I highly recommend you memorize before you take your exam 1 in Calculus 1. These trigonometric derivatives will definitely be a part of your problem statements. So not only do you need to know the product, quotient, and chain rules, but you'll definitely need to have these definitions memorized just to make your life easier and make sure you don't get any simple things wrong. That's all for this video. Thank you guys for watching. Please like and subscribe, and I'll see you in the next one.